Hi, my name is Minh Anh Nguyễn, and in this video, I will demonstrate my custom program for the OOP unit. Its name is SoNEAT. So basically, it is an endless runner game where the player can control the Sonic to avoid the obstacle and get the highest score as possible. And they can also train their own AI algorithm using the NEAT algorithm so that the Sonic can play the game itself. The name of the program is the combination between Sonic and the NEAT algorithm. So I call it SoNEAT. So this program will not only allow the player to play the game in normal mode, but also allow them to train the AI and observe the learning process in real time. This can be a very valuable educational tool because it demonstrates the learning process of the genetic algorithm in a very interactive way. I will now move to demonstrate my classes for the program. In total, I use 46 classes for 4 different purposes. First is for the game logic, the NEAT algorithm, the user interface, and some classes for the utilities. This is my class diagrams. I divide them into 3 different groups for better visibility. First is for the game logic, the NEAT algorithm, and finally is the user interface. Okay, we can move to the game logic. I use in this project 7 design patterns, and I will explain them along with the following diagrams. For the game logic, there will be a central class, game object, and most of the objects in the game will inherit from it: obstacle, ground, cloud, and Sonic. And the first design patterns I use is the abstract factory, because I need my code to work with different groups related to different game objects like the obstacle or the environment. And this is helpful because I want to add new types in the future very efficiently. The next is the factory design patterns. It is used to create a specific objects based on the inputs like the game speed or the position. And I don't need to repeat the creation logic in different places. Next is the strategy design patterns in this interface and this abstract class. These design patterns allow me to change how the objects are spawned in the game. This base class defines the general behavior like calculating the next spawn, and then I will customize it with these 2 smaller ones. One for the cloud, one for the obstacle. And by swapping out these strategies, I can easily adjust how things appear in the game without changing in the core code. And finally is the template method pattern. It will define the basic steps of handling the objects and let the specific manager fill in the details. So this base class will provide the structure of updating, check spawn, removing the objects, and these 2 environment and obstacle manager will take care of them by following the structure and filling in the missing parts like the switchboard method. And next is the NEAT algorithm. This algorithm I only use 1 patterns, which is the prototype design patterns for all the clonable objects. The agent, genome, node, and connection all implement the prototype pattern. Because all these classes need to be cloned throughout the training. So with these design patterns, I don't need to know what inside the object class to create the duplicate. I don't need to recreate everything from scratch. And finally is the user interface. In the user interface, I use the singleton and the state design patterns. The singleton, this screen manager is a singleton class. which means only one instance of it exists throughout the game. This will ensure that the screen transition are managed consistently and globally. It also manages the frame rate of the game. And along with the singleton is the state design pattern. It will handle different screens in the game. And they all can update, draw, exit, and enter the state. Each of these specific screens will represent a concrete class that the game can be in, like the main menu and two different game screens, the normal game mode and the training screen. There will be also a subscreen, which also is a state design pattern. So together, the singleton ensure that there is one central control point for the UI, while the state design patterns allow the game to fluidly transition between different screens and states. And now I will demonstrate the program. This is what my program looks like. First is the normal game mode. So the SoNEAT, it can jump by press the space button, or it can duck by using the down arrow key, like this. And you need to avoid all the obstacles. You can also do a trick when the SoNEAT is in the air. It can use the duck to make it touch the ground much faster. When it collides with an obstacle, there will be a game over. You can retry it, play again to get a higher score, or you can back to the main menu. And the next feature is training the AI. The user can choose a pre-trained model by typing some name of the model. This is an invalid name, so there will be an error. Or the user can retrain everything from scratch. So like this, the user can also press the F button to make the training process much faster. It's very efficient when you want to demonstrate it. So this is a neural network. There will be 6 different inputs and 2 outputs for 2 actions. And this will show how the SoNEAT using the inputs to play the game. There will be, this number is the alive number of the SoNEAT. There will be 5 different SoNEATs trying to play the game simultaneously. And this is the number of the generation. So this is a small generation, the 7th generation. So the neural network is not complicated. But if you keep training and training for long enough, the neural network will be very complicated and SoNEAT will become much more smarter. You can also save it with a name like this and resume it to use that checkpoint later on. So this is the generation 11. When I back to the main menu and choose the test model like before, everything remains unchanged. This is a checkpoint and you can use that to keep training the SoNEAT. So it's become more complicated. And let's see how it performs with a model with 100 generation. So as you can see, there is a lot of connections and nodes between the input and the output layer. So now the SoNEAT knows how to use the distance to the next enemy height, and the game speed. So it becomes very, very smart right now. It do not use these 2 inputs, but that is still enough to play the game. So I will fast forward to see how it performs in the last step. Now let's back to the normal game speed, and the score has already reached 8,000, very impressive. And as you can see, some of the SoNEATs even know how to use the duck action. to touch the ground much faster so that they can jump back again to avoid the next obstacle. So incredible! Finally, a 10,000 and there are only 6 SoNEATs left. And look at those movements, isn't that insane? They are doing so great right now. Oh my god, and unfortunately, they cannot reach 11,000. But they are smart enough to play in a high game speed like that with outstanding performance. And now you can save it and then save the checkpoint and then train it later on. Or you can back to the main menu and exit it. So that's everything I want to show for my custom program. And in this user document, I will explain my program with all the classes I use for the project and all the design patterns I use along with the class diagrams. And thank you for everything.